Okay, here we are going to find normal to a curve. Okay, normal to a curve means, first of all, we know how to find the curve equation, all those things. Okay, here the question is something like this: y equals to 3x minus 5x plus 1. This is our graph equation. At this place, when x equals to 1, we know how to find the respective tangent for this given quadratic function. Okay, we know how to find the tangent. That means, okay, tangent means when we draw a straight line through x equals to 1, where is the place it intersects with the graph and its respective tangent. Okay, its respective tangent means the line which is touching that particular point only in this graph. Okay, the line, okay, the straight line which is cutting only at that place, only that line intersect with this curvy parabola. Okay, this is our tangent. We know what is our tangent. Now we are looking about the next topic, that is normal. Normal means the line. We know how to find our tangent. No? Know how to find our tangent. Normal means the line which is perpendicular to a tangent. This is called as normal. Okay, this is our normal in this case. This is our normal. The pink color one. Pink color indicated one is our tangent for a particular point. Okay, when x equals to 1, how to find the tangent, we know that one earlier. Now we are going to look about the next step, that is normal. Okay, normal, that means the line which is perpendicular to the respective tangent of a given curve, okay, or given parabola. Okay, to find that, the thing what do we need to do is we have to do some series of steps. Okay, first of all, you should find gradient of the graph. Okay, gradient of the graph. To find the gradient of the graph, we have to find first derivative, that means dy upon dx, that is the derivation 6x minus 5. Okay, 6x minus 5. The x value which is given as 1. Okay, when x is equals to 1, so for that we have to substitute x as 1 in this derivative. So that will give you 6 times 1 minus 5. So 6 minus 5, that will become 1 again. So we found our gradient of the new normal. Okay, gradient of new normal. And another new thing for you, that is when we draw, okay, this is our straight line. Okay, when I consider the gradient for this line as m1, gradient for the new line, the line which is perpendicular to the pre-existing line, this is m2. If these two are connected in perpendicular relationship, so the multiplication of these two gradients will give you -1. Okay, the thing, okay, we studied this part in straight linear graphs. Okay, straight linear graph formation, how to find the equation for perpendicular graphs. At there I told you that if this graph's gradient is m1, this graph's gradient is m2, if these are connected by using a perpendicular relationship, multiplication of those gradients, okay, those gradients will give you -1. Okay, multiplication of those gradients will give you -1. That's the thing we have to amplify in this question also. Okay, that is the thing, exact thing we are going to amplify in this question. Okay, now we found our gradient. Okay, now we found our gradient here, but this gradient belongs to this tangent. Okay, this gradient belongs to this tangent. To find the normal's gradient, we have to use this method. Okay, we have to use this method. Now we know the gradient of tangent here. Okay, the gradient of tangent equals to 1 here. Okay, 1 here. By using the relationship, okay, I'll consider it as my tangent. Okay, this one as my tangent. So m1 equals to 1. m1 equals to 1. We don't know what is the gradient for our normal. We don't know what is the exact gradient for our normal. That's the thing we are going to find. Okay, for that, let's substitute the m1 in this formula to get our m2 value. That means the respective gradient for our normal. So m1 indicated by number 1 and m2, that's the thing what we need to know. That is equals to -1. Okay, multiplication of these two values will give you -1. So m2 should be also -1. Okay, -1 because yeah, m2 and 1 9 multiplication relationship, when you took it as a division, -1 divided by 1 will give you exact -1 again. Okay, -1 again. So the gradient for the normal should be equals to -1. Now we found the gradient for our normal. Now the relationship says, okay, the relationship says perpendicular graphs, okay, two perpendicular lines, product, okay, multiplication of gradients. That means the product of gradients will give you -1. -1. Likewise, we found the gradient for our normal as -1 in here. Okay, gradient as -1 for our normal. Then let's find our y coordinate. Y coordinate. So to find y coordinate, what do we need to do? We have to substitute the given x value. Okay, in the given quadratic function, you should substitute the given x value. So y equals to 3 times 1 square minus 5 times 1 plus 1. 5 times 1 plus 1. So 3 times 1 square means that is 3 minus 5 plus 1. That is equals to y. Y is -1 here. Okay, y is -1 here. The only new thing here is this relationship. The multiplication of two perpendicular graphs gradients should be give you -1. Okay, it should be -1. That's the thing you should know while dealing with normals. Then finally, let's find our normals equation. Okay, equation for the normal. So that normal y minus y1 equals to m minus m into x minus x1. So y, let's keep y as it is, y minus y1. What is our y1 value? That is -1. Okay, -1. Let's substitute -1, which is equals to m, m, which we found for our normal gradient. Okay, normal's gradient, that is -1, we found by using the relationship of multiplication for two perpendicular graphs. That will give you -1. In that formula we substituted m1 because we know the gradient of tangent here. So to find m2, we found the m2 as -1. That's the thing you should substitute to find your equation for normal. Then x minus the x1 value, which is indicated as number 1. Okay, then y, this negative and negative will become positive. -1 times x plus 1 plus 1. Y equals to, let's bring this positive 1 as a -1 to another side. -1x plus 1, and it will become -1. Okay, it will become -1 here. So y equals to -1x. -1x. That's all for our equation for this normal. Okay, this normal. I'll recall what we did from the beginning. First of all, the task is easy. What we did earlier. To find the normal to a curve, we found the gradient first. In the gradient, we substituted the given x coordinate to find the gradient value. Then this gradient belongs to our tangent, but the question is asking about normal, no? So we have to think about the relationship between normal and gradient, which are perpendicular with each other. So the gradient's multiplication of those two perpendicular graphs will be -1. The -1. The m1, which is, that is gradient of tangent. This is gradient of normal. Okay, we can substitute it as 1. Then let's equalize it with respect to -1 to get the gradient for normal. That's what we found it as -1. then y coordinate. It's very easy. You should substitute x as 1 here. We found y as -1. Then y minus y1